Okay, I got my parts arranged, got the appropriate tools out, and now we're ready to go. So I started with this is the connection to the transmission controller. I just taped it. Also used a different color tape just to say, hey, there's the tape that I put around there. And it comes with a loom, and you have to use the factory connectors. So I'm going to solder those in. And I'm getting ready right now then to put the vehicle speed sensor on, and the instructions are sitting right here. My various sizes of heat sheathing are right there. I stuck 2 pieces on here. I stuck a piece of 1/4 inch up here. Excuse me. The VSS vehicle speed sensor wire has the standard wrap to eliminate frequency interruption or noise. And then this is also wrapped in foil. The part that I cut off, or the excess, is right here. And the foil in this case isn't wrapped like tape. It's got a split down the middle, and it is just the width as necessary. So I'm going to save a little of that. I'm going to, after I finish soldering, then I'm going to go in and wrap some down before I pull the sheathing over it. So at this point, I'm just going to clip my connectors. Oh, I suppose about a 1/2 inch, or clip my wires about a 1/2 inch with a wire stripper. Stuff like this, you don't get in there with a wire cutter and try to strip it. You take several strands with you, and especially on some of this newer stuff, the wire gauge is so close to meeting the requirements, the current requirements of the circuit. You don't want to take, and they're fine strands. You just don't want to take 30% of the strands away and to create a solder joint. Then get everything wrapped so it will come together. I try to keep my wrap outside of the insulation, not on top of the insulation. Again, I've got my sheathing on here, which is slightly bigger than the sheathing. I keep calling it that. The heat shrink typically goes down to turn the power on here. Typically goes down to about 50% its original size, between 30 and 50%, and I try to keep it as close as possible to the wire gauge that I can. When I wire, I start in the middle of the exposed strands, and then I wrap. But I keep that wrap within the confines, and I play with it. I spend as much time as I can doing this because I don't want big bulges and stuff like that in my wiring. And then when I finish wrapping it, I make sure that it is not ever over the top of the wire sheathing. I use electronics wire from a company I used to work for. They had a pile of this solder, and I still have quite a bit, and it's probably 0.40 in diameter and 40 thou in diameter. And so I just pull off, if I want stuff like this, I'll pull off a length, and then I'll twice as long, fold it over itself, and then twist it together. You know, you can do 2 times, you can do 3 if you want, or 4. a lot of guys like a gun where you have a little point on it. This Weller, I've had a lot of good luck with this style of gun, and the reason why I like this is that when I let go of the trigger, it's done. Right, it shuts off, and I know it might add a little bit to the time, but I prefer it that way. Then I just make sure I get it hot enough so I can tin the end. Okay, she's just starting to take. Sometimes it takes a little while to heat up the wire. You want a little tin or solder on your gun, so you dip that wire in a pool. It transfers the heat so much quicker. So much quicker. Oh, come on. And you notice that, that connector fell, and my wrap didn't come undone. Okay. No popcorn balls on the on the wrap. Come on now. Because of my age here, I think I'm a little shaky. I think we're starting to get there. Yeah. And I want to cover the full wrap. And I want to get a bunch of solder wicking in underneath the sheathing, because the solder joint is a hard, brittle joint, and so you still want some flexibility. And notice I'm 7 inches away from the connector, so I still have flexibility at the connector. One of the nice things about this kit too is that, at least for this start, well, throughout the kit, it mirrors the OEM wire colors, and that's a good thing. I still read it, and if it says just match the OEM wire colors, that's great. If I get into a section where it says for model years whatever to whatever, it was those are the wire color matches. Yours may vary. If you're outside of those model years, then of course you got a little more work to do. But they identify the pinouts on the connectors too, so you pretty much know that way, regardless of the wire colors. But the wire color thing is sure faster. Again, I'm waiting for the solder to wick up and start to turn that copper wire silver. Come on. I got a holder too, made out of two alligator clips. I have a contact issue on my gun. Yeah. Sometimes when you're soldering, this tip goes in through a couple of Allen screws, and when you're soldering, you sense the vibration of the current going through the transformer in there. And if it starts to go down, the vibration goes down. It's taking less current, and if it's taking less current, your soldering iron has a resistance or a connection. It's not good. And it's not that they're not tight. I know if I put an Allen wrench on them, give them half a turn, all of a sudden it'll be great. So sometimes I just push it down against the surface and get that connection back. This soldering iron is probably, 30 years old. The reason why I like it. Okay. Okay, we have two solder connections. Vehicle speed sensor is wired in, and now cover it in the heat shrink. I got no pokies. The heat shrink rotated over. Oh, I got one little pokey there. One little strand sticking out the side. Must have raised or stuck to the soldering iron. A lot of times the taper on your wire cutter, if you look at how they sharpen the jaws, there's a taper and you can't get close enough. If that's the case, get a smaller wire cutter, or what I like to do is get a needle nose pliers, or even regular pliers, and because the solder is soft, and I just want to make sure that I'm not going to poke into or through the heat shrink, then I'll just make sure that any strand tails or anything sticking out are out of the way. Push down. You can run your finger over it if it hurts. You've got a strand sticking out that poked you. Then get it over the. Oh, I got one right there. I still didn't get her cut off. She's so small, not even a 1/16 of an inch. There we go. And get the heat shrink over it. Make sure everything is nice and straight at the connection. And get her shrunk down. And then I'm going to try to simulate that wrap a little bit. Okay. Not a little bit, but I'm going to try to simulate that wrap. Interestingly, this 2000 did not have that wrap. A little while back, if you've been watching the videos, I put a Phytech fuel injection system in a Ford. Excuse me. And that wound up giving me noise. That would say, I would get on the Phytech whatever, their little module, the little monitor you could plug in and watch the various sensors. It would give you a missing or lost ignition signal. And so I went back in the harness and twisted the wires. Twisted the wires, because in that loom, they were alongside the various things. The oil sending unit, which is, in that case was just for the gauge on the dash, and temp sending unit, again, same thing. And then it had also the engine temp sensor for the Phytech, was in there. Not a lot of wires, but I twisted those wires in that loom and got rid of that noise, got rid of that condition, failure mode, where that controller kept losing the signal. So that was quite interesting. So now as I go over the with the shield here, I see that, you know, as I get through the heat shrink, it's getting wider. So what I'm going to do is just get some more off of the factory stuff, and just make sure that I'm fully encapsulated in this aluminum. You can use aluminum duct tape, anything that's basically conductive. It acts as a shield. Many of you probably already know this, but it's still beneficial. But I like to get it wrapped so that it's two things. Number one, good and tight and sealed. Maybe that's two things in its own. But then, so the third thing would be aesthetically pleasing. So once I put the heat or the wrap over the top, it would take a pretty good eye to see that that I put a solder joint in there. Can't find the parting line here. So I'd hate to be the person on the assembly line having to wrap this stuff. Gee, me Christmas. I'm sure they pull it and wrap it. I mean, I wouldn't do this by hand. I'd lay it out. I mean, like I'm doing it right now, but I'd lay it out flat. I have the tape reel coming underneath it, and apply it, and then have two rollers, you know, roll it up, and then two more rollers after that. Say two rollers at about 45 degrees, and two rollers at 90, and two rollers at inverted 45. I'm not going to do the math. 135 and whatever, 225 to just kind of roll it over. Because just by hand stuff on something that's a half-inch wide over a couple of wire strands, man, what a pain in the arse. But I digress. Anyway, so now we're wrapped past we will be wrapped past the solder connection with the foil, past the heat shrink, nice and tight, and then now I will pull my sheathing or my enemy Christmas heat shrink down, and I'm going to pull him guten far, not so far that I can't see the wire colors any longer. I got it under that aluminum. There we go. But I want to see the wire colors. I want to get everything tight together, and then of course I'll put my wire loom on it. Now this 1/4 inch is quite a bit thicker. It's a commercial grade. Takes it substantially more time to shrink it, and you have to get all the way around it. But it's thicker, and it's just really, really robust. There we go. So now we've taken about what so far? About 2 feet, right? About 2 feet out of this thing. Maybe a little less. And then this will get the brand new convoluted tubing or sheathing that's up there on the table. And I'll tie that in. That'll go into the larger tubing or larger sheathing on the, no, I'll find it. I must have pulled it off, but I'll find. Oh, it's right here. There we go. Always takes a little time with this convoluted tubing. Wire wrap, wire loom. But off to May. You guys know an easier way. I try to bend it over, you know, a little better than 90 degrees to open up that gap and then push it on. That's the method that I've been using forever. I don't use screwdrivers or anything to open it up and shove the wire in, but I've tried, you know, introducing it on one end and trying to slowly slide it up, and I don't find any luck with that. There must be a method that you guys use out there that works for you. And if you got any ideas, I'd love to take those, because I find this being kind of too meticulous. Takes too long. Yeah, I see even the sheathing is kind of pulled back in some cases. But nonetheless, I'm sure it's when they inserted it into the convoluted tubing, or when I pull it off. There we go. Yeah, it's me pulling it off. Just make sure that's all good and intact and fully wrapped. There we go. So now we've got the VSS, vehicle speed sensor, wired. You can't tell where I made the connection. If you sat and felt and did this, you'd find it, but that's done. Now for the rest of them, I'll have to go in and continue reading the instructions, and I'll continue following that protocol and get the transmission side of the controller or the setup complete, and then we get into the meat and potatoes. Well, okay, so get it in here a little closer. So we know we got the VSS wired. And in this case, now I've wired all 8 connections to the OEM socket for going into the transmission. And I staggered, as you know, as reasonably as possible, the cuts, so that I don't have a big you know, lump in the harness. This last wire here is for those electronic transmissions that have the an electronic shit. What do they call it? An electronic. This guy right here, and a range selector. Yeah, a range selector, so that when you're shifting, you got that little digital PRND and so on and so forth on your dash. I don't have that. This is a 2000 transmission, and as I learned from those instructions, it's an early 2000 because of the style of connector going into the range selector. So the function So this wire is then I just tape it off and enclose it in the harness. It's not used. Everything else is then controlled up here. Everything in this harness is 5 volts. This is the 12-volt signal that comes down and does some of the work in the transmission for engaging the torque converter and that kind of thing. So that's that. That's that. My other guy, then for I'm lost. Oh no! Right here. Right here. This connector then that was in that same harness is the basically tells you whether you're in park or reverse. Activates the reverse lights or the park lights, shares the ground, and provides those 2 signals. So I'll chase this all the way back up in the harness. It more than likely will not be going to the PCM. It more than likely will be going to the dash, one of these connectors in the harness up in here, because it functions as the reverse lights. And when the vehicle is in park, what does it do there? I don't remember. Anyway, so I'll chase this back. So at this time, I'll begin then pulling all of the wires back and through the harness and remove those, isolate those. Those that go to the PCM, which will be these 8, because the PCM controls the transmission shifting and overdrive functions that are provided by this transmission. I'll clip them short to the connector and remove those from the harness. Then as we get into the MicroSquirt, then I'll have that portion of the harness exposed, that portion of the harness eliminated, and of course the goal is to remove all the unnecessary wiring from this harness and have a new one. You can see that I made that the same length, basically. Came down, routed, taped off, and I'll finish wrapping the wiring now. I'll probably tape around here first. It's like the OEM, they just do a long banded tape to kind of keep things collected and together. Here you can see it again up here. And the thing is that it keeps that isolated. You want to come in, and when these Y out, I typically tape and bring the strand of that tape up through the slot on here and then seal that connection to this. A lot of times I cut a little V in the groove so that this isn't opening up the tubing, and that assists as well in keeping everything sealed up. But the first order of protocol at this point then is to get that wire that I lost again right here, is to get that guy pulled all the way back from the harness and to make sure that I'm to validate it, isolate it. I really don't need to change the length because the length is good, but I will want to get it into the transmission harness, probably up here somewhere. It might be in this harness here, and I'll transition to the transmission harness so that my transmission harness then is isolated from my engine harness. That's kind of the plan with that, and we'll push forward. Well, we're approaching 5:30 in the afternoon now, and I got a lot of wires pulled out. I can't. Some of that stuff is the data connections, to the port, ALDL, or the socket you plug into when you want to do diagnostics with a ODB2 style connector. And some of the other stuff there is the VSS and some of the outputs that were on the PCM that didn't have inputs. I'm using, I think I mentioned that in the earlier video. So I got rid of some of that wiring, and then I'm back into the harness, and so far I've got 4 wires into the, whatever it is, 30, I think is a 36, 35, maybe it's a 35 pin connector. I think that's the last page. And basically, as I've gone through it, I've got the PCM wiring diagram for Dodge. I got the color chart, you know, that I used to originally wire it up, and I'm just kind of bouncing back and forth. I've labeled everything, and as I go, I'm slowly peeling things out and refining the harness. Actually, the way it's going quite well. This is all the dash wiring that will come in. And pretty much all of this wiring will go together, but there will be a larger loom now instead of three or four separate looms. There will be a larger loom that comes in one bridge that will tee off in the same location, but will come up. And it's going actually quite well. It's just meticulous because you want to validate that your wires are right and all that. And there's too many warnings in here. You know, don't ground a 5-volt sensor signal. Don't apply 12 volts to it, and you know, it goes on and on and on. So you want to make sure that you do everything right, and there are tests to do as well. So it's going fine, but I am done for the day. This is a long, slow process. All right, so we're on 3.5 days. 2.5 days. 2.5 days. Started on a Monday morning. It's Wednesday. It's Wednesday, 11:35. I start at typically between 4 and 5 o'clock in the morning, so they're longer days. Whatever. So, what was the original controller is now the MicroSquirt. It's pinned out to the existing harness. What is tied. What requires engine ground is engine grounded. What requires common ground to the controller is grounded to the controller. I have some chassis grounds. These will be for the interior side. But all in all, I went from a box that you saw in an earlier video to this box. But in order to run this box, you need a transmission controller. So that's this box, because this doesn't control transmission. And it's unique to Chrysler electric automatic. To run this box, you need to know any box you need to know O2 signal. And I wanted a wideband, so that's this setup. That goes to the O2 sensor right there. And then you get another 47 feet of cable, and then there's the controller right there that reads back to the MicroSquirt. Then, of course, you got the transmission, the O2. Oh, and then to drive a single distributor ignition coil to fire, you need an ignition module. So now you start to look at the real estate, and of course I separated the looms because I put, you know, space, like there's 3 inches here. These wires are going to run. This is a 5 amp, no noise 5 amp control for the O2 sensor. I'll pull that off the fuse box strategically. That's a bootloader. That's for resetting that. If I want to do that, you just simply hold that wire to ground. But now, of course, everything at this point that goes into the interior of the car is setting here. You know, and I got the harness that runs out to the heater motor and everything else. These come off the ignition. These were in running the original computer. Another thing that happened is, you know, you get into 2000 and so many things were controlled. The evap canister, the cruise control. So I lost the cruise control. But the alternator is also the field is controlled by the ECM or PCM, whatever you want to call it. And so now I got to go find a traditional up through late 80s. The later the better, of course. Voltage regulator to drive the alternator, because the voltage regulator was integral with the PCM. Not a big deal. I mean, it's not that big, but it's just another thing on the firewall, and that's also spaced. So now, the top side of my firewall, I'll have to make a mount where the PCM mounted, and that was because it took up a chunk of real estate. That'll work fine. I'll just make a mount, a flat sheet that I can run sheet metal screws into to mount all this stuff up. But it was a heck of a journey, and it's certainly not for the faint of heart, because each one of those has unique characteristics that you have to make decisions on as you go. And to make a decision, you need information, and then you got to go research the information and all that kind of thing. That alternator thing threw me for a loop. Even though I knew it was going to the PCM, I thought it was more of a signal, and whatever. I didn't even think about it. But the long and the short of it is, then you wind up soaking a whole bunch of research time on the internet. I have a service manual for this, which gives me wiring diagrams. And if you're not comfortable with wiring diagrams, you can't be comfortable doing this. So, and pinning it out, it gives you brief descriptions of what each does and what the options are. And that's all decisions that you make as you go through the process. Once you've got those made, now you're hardwired literally to that decision, and then you go in and start doing the software side, and things are subject to change, of course, at that point. So in this case, I just put this convoluted tubing over the top of it to keep the wire together. The rest of it is all good, but as far as going to the pins and that, should I need to change, because you can see I'm not fully populated in there, because I don't need to be. I don't have certain features, and some of the pins are redundant. If you use this one, you can't use this port, you can't use that port. And that's 6 pins if you use 2 of them. If you use those 2, the other 4 are just open, void. There's also only one actually in this that's not used. So in addition to that, the documentation, because I have a MicroSquirt, you don't get tech support, and you rely on the documentation. Well, there were errors in this documentation, and when there are errors in documentation, of course, you wind up having a wire that's called for in a different section of the document that you don't have a pin to place it. So then I found online, I did call tech support, and they referred me to a location online. If you install MicroSquirt, and it has said, and I've read this before, and I was told at the sale, you have to print off the 155-page installation. This guy here is about 40, I'd say 40 pages that I just printed off the net. And that 155-page document is a lifesaver. So it has a few examples in it, but it gives a lot more clarification and explanation. So I could have used my narrowband O2 sensor, my factory one, to drive a signal to this. But because of the type of controller this is, the more control, the more information you can gather from the O2 sensor, the better you can tune your engine. So in all RPM ranges and under all loads. And so that winds up being helpful, because it keeps that data, or it uses that data. It doesn't use a portion of it. So that's great information for me. And of course, the next challenge then is to go in and start loading the tuning, and then playing with the tuning and all that kind of thing. And of course, obviously, because I'm not sitting with the body, I can only get this to a certain level of run state. I can't really load it, that kind of stuff yet, but I can get it to a certain run state. So this phase, the wiring phase of the project, is what I would call 95%. The 5% are the variables that I overlooked or did not address, but not purposefully. obviously the two hanging wires there, one would be a switch to ground, or I would just cap a clip and hold it on ground for and turn the ignition on and then reset it and then release it from ground, but it would have to have a cap on it. And the other one is going to the fuse box, which is in the body of the car. So that'd be a plug-in kind of scenario. Everything will be able to disengage. That's the beauty of doing the chassis, the wiring from the chassis to the body, is that you're relegated to having connectors, a method of removing the wire without cutting it. So that kind of keeps your head straight, because when you're laying under the body and when it's on the chassis and you got these wires in your hands and you can't think of where are those running through the firewall or are those running to the fuse box, those kinds of things. So very happy. The sacrifice was the cruise control, so I'll have to get an aftermarket cruise control. I certainly want to have cruise control. I did not, by design, this one does not have air conditioning. If I decide to, and I yanked all of the wiring for the air conditioning and the cruise control out of it, there's a lot of wire that came out of this. Not that much, but a lot of that's on top. I mean, that's how organized I am with my wire, because I throw it in there. You throw a spool in there, then you grab the wrong edge of the spool, and then, anyway. But so a lot of wire came out, and at this point now we're just going to have to power and ground the controller, hook up the data line. I'm waiting for the serial port. The serial port will come in. That's a couple of pins, 3 pins, ground, transmit, and receive. And it's a 9-pin serial port. And then I also got a serial to USB so that I can plug my laptop in, power this thing up, and take a look at if there are readings on any of the sensors, ambient air temperature, throttle position sensor. So I can see all of those things. And if I have any errors, do that before starting, and check as much as you can. This thing hasn't fired for over a year now, so I'm pretty excited to be able to get to that level, but we're a few days away. So the good thing is, at this point I can move on to something else, because I'm comfortable that what I've got is ready to go. I've checked it, double checked it, and triple checked it. And it meets the specifications for the pin out diagram, not necessarily the instructions, because there were some errors. The pin out diagram that was checked against both documents, that one and the one online. So I have high confidence that everything is where it needs to be. And at this point now, I'm going to move on to something else for a little while. Well, got one side done. Tell you what. So I took about an inch out of these to bring it up so I could clear the steering. I mean, you saw that in the raw form. But that header tape, that puts on a significant amount of thickness. Getting those bottom bolts tightened with me taking that inch out and then wrapping it. Whew, to May. But it looked good. They're wrapped. That'll keep the heat going down. And then I also built a heat shield in and behind the header. You can see it down in there. It's an aluminum heat shield. I put high heat wrap on the wires going up front for the fan and the crank position sensor, and then relocated everything directly under the pan. Fabbed up a bracket that holds the clips now. These lines were kind of tied together. They were touching each other, but now they're not touching each other all the way back. And the heat shield might be overkill now that I'm not even, I'm more than an inch away, but it's spaced about an inch from the lines and about an inch from the header. So, and it stands out from the brackets that hold the lines. It stands out so that the only points of contact are the shims between the heat shield and the and the mounts for the transmission line. So I got airspace on both sides of it. So that journey is done. And now I got that side to do, which will be substantially easier. I didn't hug it as close to the engine block as I did on this side. So, but it tucks down in there, you know, tucks down in there. It'll stay considerably farther away from the hood too. Moving on. All right, passenger side complete. Again, plenty of space down in there. And everything's bolted up. This these headers, this side, the pipe is in contact. That pipe's in contact with that pipe. That pipe's in contact with that pipe. In fact, on the other side, I was able to just get a wedge in there, a punch, and spread them a little bit. On this side, they were right up in there. In fact, there were some welds connecting them, and I wasn't going to bend them up. So I do have a little bit of a gap right there in wrapping them. But I'm down into the collector on both sides, and I'm happy with it. So, well, not a heck of a lot to show, but I did want to show how this thing turned out. I'm very, very happy with it. So I've got all the knobs on, and that's the piece that goes into the console. It's finished up. I had a local sign maker print, color print the display, and then laminate it. So you get all the effects. It uses modern technology, modern trim, you know, modern look, and I'm really happy with how it turned out. I put all the miscellaneous pieces into it and put the knobs on, and I'm very happy with it. That's one of the things going on. Upholstery, the front seats are done. Paid the first bill, and you know, that's moving right along. Went to the pick and pull and grabbed a canister. Now, originally I wasn't going to do a canister, but I got to back up here and mute this TV, listening to the news there. So I grabbed an evap canister. And originally, as you know, I was evaporating through my gas cap, and that's my vent running over to that line. I mean, if you watch the videos on the construction of the tank and what I'm doing there. But after a lot of consolation and discussion, these things sit, and they sit in your garage, typically in an enclosed area, and of course they do permeate or fumes if you're not capturing them somehow. So I started out with the forward look, and I may have done a little bit on that in the past. I tore apart that 79 F-150. He didn't want any of that, the donor frame, and started investigating the hose routing and stuff like that. And I just didn't like that twin canister thing. And my packaging is so difficult in here anyway. Behind this, behind my my coilover tower, is the battery, and the battery recesses down to just above the top of that rear apron. And so, you know, I maybe have some room here or here, but it'd be too close to the exhaust. No room in front. You know, same problems on the sides, but the housing will hit it. Remember, the car's got no body on it, and the coils are nearly fully extended. So it's all the way up. It's only, the differential is only going that way in the frame from here. So I opted for the frame rail. And what I did is I just kind of poked around in many cars, foreign and domestic, looking for a solution. And here it was. This was out of a Geo Metro, and they're mounted right on the firewall. But the nice thing here is this has the electric solenoid for vapor. It's got the port to air on the bottom side. I know I'm upside down. And of course the vent going back to the fuel tank. So I bent up some 1/4 inch line, made sure I could get out of the way of this. So if I needed to wrench on this, I could, and I could wrench on this, and basically I could get this thing apart. And then I terminated right here with a flange, and from there it'll be rubber hose. I do have a piece in there, just kind of as a test, but I think I left it in there. I was going to try to do continuous. It's impossible to route continuous. So what I'm going to do is, put my hose on, pull it through, put a T on there. So I'm sucking vapors from the tank. Of course, I'll replace the gasket. I wanted to replace that gasket. It's too small anyway, but I wanted to replace it with something a little nicer. And then ran that solenoid cabling up. And I have a wire channel for my battery positive, and on the original car, there was a battery temp sensor that I'm not using with my MicroSquirt. So I'll take the 2 wires from that battery temp sensor. I'll do a weather pack plug. It'll plug in, chase back up the firewall, and I'll use those contacts up here. And doing a little research on the MicroSquirt, I've got available ports, and I'm learning as I go, right? Just researching and learning. But you can see there's 36 ports, but I've got quite a few available, some of which will be used for the dash, the turn signals, some other analog related activities. Of course, the digital related activities, the tach, the speedometer, that kind of stuff will be through the serial port, which I also have connected to now. So I'm almost ready for communication with the unit. And back to this, I routed the vacuum line up, terminated it right here. It goes up and grabs the only available vacuum on here. And I think what I'm going to do is, if I can use the MicroSquirt, which I believe I can, and an available port, I'm just going to open that solenoid after 1,000 or 1,500 RPM. Probably something underneath highway speed, right? Steady state, where I'm sucking the vapors off of the tank when the vehicle's under acceleration and things of that nature, But certainly at all times off of idle. You don't want a vacuum leak at idle. So if that doesn't work, I can restrict it and do a very small purge. The computer will compensate for a small leak, but right now it's 1/4 inch line there. That's 3/16 going up to the vacuum. So I'm already kind of hesitant, but that was the original line size on the Metro, was a 3/16 hose. So I'm probably at this point rambling too much, but anyway, I am going to go with that canister. Other than that, I haven't done a whole bunch. Of course, everything is set up here. Oh, I tested the sensors, did the water boil on the intake air temp and the engine coolant sensor. While I was at the pick and pull, I grabbed new connectors because mine were so fatigued in use that I grabbed some more really good connectors. Since Dodge uses them up through the years, you just got to find the right connector and cut it. And I just pulled the pins out, took it apart, pulled the pins out, and put the new plastic on the end of my connectors. Other than that, we're just still dinking along here, but I will, in short order, start the process of analyzing this on the MicroSquirt and seeing what I can do to fire this thing up. So more later. Okay, what did I do today? I powder coated the spare tire. Now this was, if you don't remember, or if you didn't watch that episode, this is a Dodge rim. I opened up the center hole. I flipped it over. This is the back side of the rim. Flipped the center over on the rim and welded the center on backwards so I could get the offset, achieve the offset, because this is the only space that you can mount the rim on. So the valve is on the inside, which is no big deal. Tire, yeah, I had this tire. I bought this tire new for a trailer. It's a 215/75/15, so the diameter winds up being perfect for my application. But I yanked two screws out of it, checked for leaks, and got all that set up and ready to go. So my spare is ready now to mount. And when I get the mount mounted, mount sitting on the floor right there. And today I drafted and cut out a couple of decorative spark plug wire holders to keep these things from getting in the way of the hood. And they go on to, the Hemis had spark plug wire covers on them. So I'll just grind these off. I'm going to keep these two and use them because they keep everything nice and back. You can still read Chrysler Firepower. And then they just sort the wires, and then I'm going to get another clamp on back, another separator on back to hold these so they can move those around. I'm going to do the same thing over here. Made one for that side as well. I just got to powder coat them. They are unique though in that, of course, you can see when I put this on the driver's side, the hole locations are different. So I did a pattern that allows you to pull the plug on both sides. So that big eyebrow allowed me to have the space for this plug, but I had to move the arch from this location on that side back. And other than that, the outside and top side are symmetrical. They're the same. But it looks pretty cool. I'll powder coat those black. And maybe aluminum. No, probably just black because these are black. I just drilled and screwed 2 screws in each one of these. Getting 2 screws in that one was a difficult one, but they're 1/4 inch wide, so they're number 4 wood screws. So I drilled a 3/32 hole in each one of these and got them in. They are 2, 2, and 2. And I just welded this, tigged it to some 14 gauge. The wires are holding it up right now, but they slide over down flush with that tube, and then they'll just bolt on. I'll get some nice, I think I'm going to use button head caps to hold that down. So that's what I got going today. All right, still just clunking along. I'm going to back up. My camera defaults to that setting. I need to go back. Anyway, so I got that finished up, cleaned up the scratches on the front, mounted the radiator, wired the radiator in, hosed up the radiator, top and bottom, top hose, bottom hose. If you remember in an earlier video, powder coated all that stuff, but the stuff that was painted, I just resprayed that, got the frame rails cleaned back up. It's still curing, but I had a lot of scratches on the frame rails from all the activity. The rest back is good. And then I quick fabbed up a mounting lug for my ground and my body to chassis ground, and then my battery ground. And I basically just took a piece of 5/16 and I plunged it. So this is a 5/16 bolt. This is a 1/4 inch bolt. That's my chassis ground, or any other grounds that I want to bring over to this lug. But I took a piece of 5/16 and I drilled a hole, a 1/2 inch hole on this side and a 7/16 hole on that side, which is similar to the size of the head on the bolt, right? A 5/16 is a 1/2 inch wrench and a 1/4 inch is 7/16. So basically what I did was I drilled a 3/16 hole through both of them, opened that one up to a 1/4 and that to 5/16, and then took a 1/2 inch down almost all the way till it touched the bottom of the hole. Same thing with the 7/16. Then I took the bolt, chucked it up in the drill, and spun it against the grinding wheel until I took off all of the edges till it was round. Did the same with both. And then while still in the drill with some stick out, I put a taper on it so that it would drop in to that 5/16 material to the point that it would, I would have, approximately 1/8 of an inch. The bolt head was approximately 1/8 of an inch into the surface, the back surface of the material, and then I just cranked the welder up and plug welded both of them into the back, and then cleaned off any peaks on the weld, and so now I have 2 studs, and then just quick welded this on this side, that side, right onto the chassis. So now I have a positive ground lug on the rear. Of course, my battery's in back, and yada yada yada. Anyway, so that's basically where I'm at, and I'm getting ready to go on a power tour. I'll give you some indication of the date here. I'm leaving tomorrow, and for Michigan, where my brother's at, and then we're gonna begin the tour in Indianapolis. So Power Tour 2025. I'll be taking the 37, and we're packed up and ready to go, and gonna enjoy that trip, my wife and I. Only other thing is I got the kit of these in, so I'm beginning the wire routing. I'm going to make sure that this looks all pretty on the backside. So that MicroSquirt is going to get up and going soon. I am on the cusp of just basically keeping videos on in the background as I work, so that I can pick up tidbits as we go. So we'll keep moving on.